Hello, hello, everyone. Thank you all so much for tuning in. We have an amazing live stream ready for y'all today. Go ahead and leave a comment and let us know where you're tuning in from. I'm tuning in right now from New York City. It is very hot outside today, high of 98 degrees Fahrenheit. How about you, Afi? Where are you tuning in from?
Hi, I'm tuning in from Southampton in the UK. It's a bit cloudy and rainy, so yeah.
I'm jealous. We've been going through like the worst heat wave ever
Oh,
recently. So it's hot in here.
yeah, I can imagine.
Yeah. Perfect. So let us know where you're coming from. If you've ever used the Beanie ODM before, what you've used it for in your projects, if you have, or if you've never even heard of it and you just want to tune in and learn a little bit more from the creator of Beanie. And I see Pedro in the chat. Hi. Let us know where you're tuning in from, Pedro. From Barcelona. Ah, I wish I was in Barcelona right now. Sounds a lot more fun than New York City. Perfect. So why don't we go ahead and we'll get started. We have such a fun live stream for you. My name, by the way, is Anaya Raisingani, and I'm a developer advocate over here with MongoDB. And I want to welcome all of our watchers, or if you're going to watch it later on YouTube, to our live stream Experience the Beanie ODM, Build Robust Data Models in Python. So this is a super, super exciting episode today as we have Roman, the creator of Beanie, here to chat with. And we are going to be covering some frequently asked questions about the Python library. We are going to chat all together, go through a hands-on demo, and then leave some time at the end for questions straight from all of y'all, from the audience. So I'm going to go ahead and I'm going to turn it over to Roman and allow you to introduce yourself.
Hey, hello everyone. Thank you for having me here. Yeah, I'm Roman. I'm a software engineer. Currently, I'm working at Microsoft as a senior software engineer. And yeah, the reason why I'm here, a few years ago, I've created Beanie ODM. It's ODM for MongoDB that uses Pydantic and PyMongo and Motor in previous versions. So that's it.
Awesome. And now over to you, Shubham.
Hey everyone, hope you're doing well. My name is Shubham. I'm a product manager at MongoDB for Python client libraries. I primarily own PyMongo, now deprecated Motor, PyMongo Arrow, and recently launched Django MongoDB backend library. Looking forward to a live stream.
Perfect. And how about you, Afi?
Hi everyone, I'm Afi. I'm a dev advocate at MongoDB and I'm specialized for Django and Python.
Awesome. Okay, now that we're all acquainted, let's go ahead and jump into our agenda for today. So first, of course, it's a very small agenda. We have some housekeeping that we're just going to quickly go over. We are going to chat about the Beanie ODM library. Roman is going to take you through the hands-on demo. It's super, super cool. If you have any questions, please leave them in the chat, and then we'll see if we're able to get to your questions during the live stream, but we're definitely going to allocate some time at the very end of the live stream to answer any questions that we may have missed and also give all of y'all some fantastic resources to learn more. So here is our housekeeping. First and foremost, there are absolutely no bad questions. So please use the chat feature and we will answer your questions at the end. So you can chat from either YouTube or LinkedIn, wherever you're watching from. And even if you miss the live stream and you watch it later on either of those platforms, still please feel free to answer your questions and someone from the DevRel team or another team will definitely try to answer your question. So let's get started. Let's start off with some intros about what Beanie is. So Roman, for those in the audience who may not be aware of what Beanie is, can you please quickly explain the Python package?
Yeah, sure. So Beanie is Object Document Mapper, ODM. Probably people face things like, I don't know, SQL Alchemy for PostgreSQL and so on. So Beanie is mostly making the same thing. It's mapping Python objects to structures that are stored in the MongoDB itself and manipulate with them. Like it can search, it can update, it can remove, and it can aggregate data. So in general, Beanie simplifies developers' life, and it supports like more Pythonic way to manipulate data in MongoDB.
Awesome. Thank you for that introduction and that explanation. I have another quick little question because you mentioned what an ODM is. So I just wanted to ask, either Roman or Shubham, whoever wants to take this one, what is the difference between an ODM and an ORM? Because I'm sure a lot of our viewers and listeners, they probably are more familiar with what an ORM is.
Yeah, happy to take that one. And ORM literally stands for Object Relational Mapper. It basically maps the objects in your code to rows and columns in a relational database. And ODM, on the other hand, is an object document mapper. It maps the objects in your code to documents in MongoDB. I think functionally, they do the same thing for developers. They let you work with native language objects and queries instead of writing either raw SQL or raw MQL commands. The main difference is in underlying data model, relational versus document-based.
Very cool. That's a fantastic explanation. If anyone who's watching has any questions about the differences between an ODM and an ORM, please let us know in the chat and we'll get to your questions. But kind of going off of that, back to you, Roman. So what was the motivation behind creating this library? Especially because we already have some Python packages such as Motor and PyMongo that already exist. So how are you hoping to have Beanie stand out from that?
Yeah, for sure. There are drivers like PyMongo and Motor, but it's a bit low level. Like people have to work with, as Schumann taught, with queries directly. While actually there are ODMs as well, like Mongo Engine, but by the time when I was creating Beanie, like it was 4, even 5 years ago, there were no asynchronous ODM for that, for MongoDB at all. And I was working on my projects, some personal pet projects, and I decided, why shouldn't I create one? And that time it was raising of Fast API, so PyIdentic stack, and I decided that everything must be compatible. So, and I created Beanie on that stack as well.
That's awesome. So can you go into some of the really key design principles that you kept in mind while you were creating Beanie?
Yeah, sure. So I wanted to, first of all, to mimic everything as possible from Motor, from PyMongo. I mean, all the operations should work exactly the same, but with some abstraction level. What does it mean? For example, if operations are atomic, could be done in a single shot, in a single command to MongoDB, it must still stay atomic, because otherwise we will have race conditions and other problems that developers will never know about and will have a lot of problems because it's super hard to debug. And only when all those features were implemented, we added more and more on top using this basic. So this was just the general principle. And yeah, for sure, we always communicated with the community, because honestly, my own usage scenario are not that rich as users suggest, like we need to do this, we want to do this, and so on. And like every time it was great ideas to add features to Beanie.
Love that. Thank you for going over that. So kind of from your answer, I wanted to ask, how does Beanie's async first approach really change the way that we not only model, but also query our data?
I can say that, so it's just a modern world of Python, and like everything should be and must be asynchronous right now. And interacting with MongoDB is, book example principle, like when we have to use asynchronous, because it's IO operation where we have to call to wait what's going on that side, on the MongoDB side, and consume the response from MongoDB. So if we will use blocking approach, synchronous approach, we will lose a lot of, like we can do everything in parallel with asynchronous, and it's very cheap because we don't have to create any threads and so on. We just can use async await approach for that. Yeah, this is just modern and it gives us much more resources to be used.
Yeah, just wanted to tail in on what Roman said. Like sometimes I've seen some users using async, even though they're not really should be using like it. You should only be using async when you really have, like Roman said, like a blocking code or some blocking operation.
Very cool. And I have a question for you, Shubham, too. So I know that the adoption of Fast API and MongoDB is rising among Python users. As like the main PM, have there been any particular trends that you've observed from your side, even with Beanie?
Yeah, there are a few things that I've noticed. I mean, like both MongoDB and Fast API are super, super popular. And as like I've been tracking this space from last few years, and every year this stack is becoming more and more popular. And now there is a term called Farm Stack, which is like Fast API, React, and MongoDB. In terms of trend, like I'm really seeing a lot of new AI ML application that is being built are using Fast API and on the database side, MongoDB is one of the top choices among other databases, just because we have added native vector search capability, as well as now with our Voyage AI acquisition, you can generate embeddings within the one platform, MongoDB Atlas platform. So it's really one of those spaces where I'm seeing a lot MongoDB and Fast API being used a lot. Another use case that I've seen is API first microservices architecture, is just because it's so easy to spin up something in Fast API, and MongoDB is also very sort of like a plug and play, because Atlas provides you the flexibility to create a cluster, deploy, not much of supervision. Everything is done for you. So it really adds a lot of velocity to what you're doing.
Yeah.
Love that, sir. Thank you. Oh, sorry, Afi, go ahead.
Yeah, sounds great. Roman, I realized that there's the synchronous version of Beanie, which is Bonnet. Could you kindly shed a little light on that, since I see more attention on Beanie than Bonnet?
Yeah, sure. So Beanie is a backport. Bonnet is a backport of Beanie to synchronous world. Like we synchronize them twice, maybe 3 times per year after every major update is happening. We don't synchronize like after every single PR because it takes too much. So what's the reason to have Bonnet? There are still a lot of people that use synchronous tech, like synchronous Flask, some Django applications, and so on, which uses synchronous. And for that, and if people want still to use Beanie, like MongoDB with Pydantic, they have to do some workarounds to make asynchronous library synchronous, and this is additional overhead of processing time, and in general it's not that nice. So we decided to support synchronous version as well, as soon PyMongo supports synchronous calls. From our side, it's not that complicated to just rework everything to support synchronous as well. So Bonnet is completely the same as Beanie but synchronous, and it consumes updates a bit slower than Beanie itself, but it's stable.
Nice. that works.
Awesome. Great question, Afi. Thank you for asking it. Perfect. So I would like for us to dive into the demo now, because one of my main questions, and I'm sure you get this question all the time, Roman, but how would you define a document schema in Beanie using Pydantic models? So if you could give us a little explanation, but if you need to show us, that would be awesome as well.
Yeah, sure. So, Pydantic is a library that gives us all the freedom of how we can use the data, use different types, and make the data nested. As well as MongoDB supports everything like this, like nestedness, a lot of fields, and any data types are supported. So in that sense, Pydantic can help with structure. Like if we want to keep a schema more or less clean, and we still want to use freedom of types, nest, and so on, but we still want to understand, like in general, what we keep in our collection and to be able to work with everything. Pydantic helps with this a lot because it can help with structure and it can validate like what you push to your database and what you receive from your database. Beanie supports a few different ways to store things. Like here you can see the very simple model user. It consists of name and email only as strings. Here you can put any data type. It could be UUID, numbers, datetime, and so on. So it doesn't matter actually. But this is kind of plain model. It means there is only one level of nestedness here. As well, we can add a bit more. Like we can, for example, for this user, we can using these models, we can add, for example, post. It would look like
Roman,
this.
so sorry to interrupt. Is there any way that you could please make your the code on your screen a little bit bigger?
Yeah, sure. Let's make it this big. Is it okay, or should I make it even even bigger?
Can we do a little bit bigger just so the audience can see?
Yes.
Thank you so much. Sorry for
Sure.
interrupting.
200%. I think it should be visible right now. Yes.
Yes, that's a lot better. Thank you.
So yeah, and here we can, like in the post here, for example, we can use user mapping directly the document or base model that was already implemented. Another way to keep nesting stuff here is references or links, as we name them in Beanie. So you can use link here as a type, as a generic type, and put a user into the brackets. So it means how will it work? User will stay in the same collection as before for in the user collection. Post will live in the post collection. We name it posts here. And outer field in the database level will be a link to another collection. But when we will work with Python code, with Beanie, everything would be fetched and we can work with everything together. And there is another one interesting thing in Beanie. You can use single collection to keep your documents in different schemas actually. Like you can create a base document, post in our case. Then you can say that it's a root document, it's a type of the document, like everything would be inherited from. And then actually make derived models that will have another field set, like summary for article, level for tutorial. And everything would stay in the same collection, in the post collection, but we can work with them all and together. Like I can get all the types of the post in a single query, or I can, for example, ask to get only articles or only tutorials or only posts. Yeah, so this is how we can organize data using Beanie. So it adds a bit more flexibility even in compared to MongoDB raw usage. Should I go next to other tema, right?
Yeah. But quickly, I believe Afi has a question.
Yeah. What are some best practices that you could recommend when defining document schemas?
So my recommendation would be try to keep everything simple and increase complexity, like with step by step, without trying to make huge schemas from the first shot. Like make everything as simple as possible at the very beginning, because refactoring the schemas later is usually a problem, an issue, and waste of the time. But in general, MongoDB, after the 5th version at least, can handle like huge schemas, huge indexes, text indexes, number indexes, and so on, and everything works really fast on their side. On our side, on the Python side, Pydantic as a validation library also was reworked with Rust, so it works much faster than before, because Python validation is slow, but Rust validation is almost as fast as C validation, so it's great. It means we have much less limitations now than we had like even 5 years ago or even 10 years ago when we were working with 3.6 MongoDB. So right now, developers has much better conditions to work with.
Nice, nice. So keeping things simple. Over to you, Anaya.
Yeah, and also just wanted to say, in MongoDB 8.0, we delivered massive performance gains. So that should also help a lot in getting a better performance out of MongoDB.
Perfect. And then, so a lot of people, when they use MongoDB, they rely on indexes, right? So can you discuss a little bit about how does Beanie generate and manage MongoDB indexes?
Oh, yeah, I think I didn't add it here, but you can use, let me import. We can import indexed, and this way we can just set up like if for example, title should be indexed, and it's a very simple way to index singles field. And we also can set up it in the settings. It would be a bit more complicated, but it looks completely the same as if we add indexes in PyMongo, because it uses the same syntax. I think I will not edit here, but we can go to the documentation. Let's go here. Because there are so many ways actually to work with indexes, because this is a highly important part of Beanie itself. So here is how we can create indexes in the settings. Why I tell that it could work a different way, because indexes is not only single field indexes. It could be compound indexes with different properties like name, like way to sort, ascending, descending, and so on. So in this way, we can create many indexes per collection just in the inner settings class for the model, for the document model. In this example, we create test int, it's single field. We create compound using just a list, and we create another one using index model. Index model is actually PyMongo index model, so we can create it the same way as we do it for PyMongo.
that kind of leads me into my next question. So what exactly is the difference between working with complex queries in Beanie and Motor or PyMongo? And this one can be for either you, Roman, or you, Shubham.
I can take this one. So when you're working with MongoDB and Python, you got a few ways. For example, Motor, PyMongo, or a library like Beanie. Working with native driver like PyMongo gives you full control over your queries, which is powerful, but it also means you're writing a lot of boilerplate code and writing complex queries, handling validation, etc. Just add a lot on the application level. Whereas Beanie, on the other hand, which is built on top of PyMongo, gives you much more Pythonic feel. It uses Pydantic model, just like fast APIs, where your schemas are strongly typed and validated out of the box. And also, when you're writing queries in Beanie, you're doing it in a more expressive Pythonic way than raw MQL in MongoDB. So many developers prefer to work with a neat interface like Beanie to write code this way. The code is much more maintainable and just scalable. That said, with an ODM like Beanie, you sometimes lose a little bit of low flexibility that comes with writing queries, for example, optimization that you may want to do in your queries. And that has been a problem with the whole ORM ODM space in general. But it's a trade-off. It's between control and productivity, and really comes down to your development style and what kind of project you're building.
That's awesome. That's good to know. What about, for other more advanced features? I believe, Afi, you had an awesome question that I saw earlier.
Yeah, I just wanted to find out what is the difference when you're creating aggregation pipelines? Because after indexes and queries, you have aggregation pipelines which help process documents and perform operations like the filter, match, and sort. So how is that done in Beanie, and how is that different from other ODMs?
So aggregation pipeline, as soon aggregation pipeline, in general, aggregation framework, as we name it in MongoDB, is a very complicated thing. So Beanie supports aggregation, but it supports it on a low level. We can create a pipeline, and we should use this completely the same MQL syntax as we would use for PyMongo or Motor or any other way to send comments to MongoDB. The only additional thing is we can fetch everything into the models. So there is no such example here, but we also can add a model here into the aggregate command, where we will fetch everything into. So the results would not be dictionaries or will not be lists of dictionaries, but will be Pydantic model. But this is all we can do with such complicated thing as aggregation framework. So what is about indexes? It still works more or less the same as for MongoDB itself, because we don't control this part. But there is interesting addition on Beanie side, how we also use aggregation framework, because Beanie supports some magic things that I'd like to show you. So the scale is a bit huge. We support links. So what link is, I before told that we can link to different collections, and we can use document from one collection as part of the document of the another collection. And in general, how it works internally, as soon MongoDB doesn't support such references, we use aggregation framework under the hood. And for this, for sure, we have to use indexes. If we need links from one thing to another, we already can use ID index, because like default ID index that is created by default for every collection. But when we need to make opposite operations, like to check for this link all the documents that contain it, we have to create other indexes, but this is already complicated scenarios. So yeah, in general, we use aggregations a lot under the hood of Beanie, and not only to make aggregations like directly as user want, but we also use aggregations under the hood to support some features that are not supported by MongoDB itself.
Awesome. Thank you for that. So then, can I ask, what happens if your Pydantic model changes? How would you handle schema migrations? How are things different or the same? Can you dive into a little bit of that?
Yeah, sure. Let's go to the documentation again. Beanie itself supports migration. It's not that simple as with relation databases, because when we work with relation databases, the schema change cannot be that complicated as for MongoDB, because MongoDB is super flexible, right? So we can, for example, move values from one field into different nested subfields and so on. And this means we have to support not only schema migration, but data migration in Beanie. So for that, we use migrations as just Python modules that we can add to the project that uses Beanie. For example, here is old tag. This is old node, this is node, and we need to migrate it. And there are different migration type, forward and backward. Why we do support both? Forward is a migration from old to new. It's just straightforward migration to make the schema and data changes. And we support backward migration. It works to make rollback possible, because sometimes after migration, some data could be corrupted, something could be not supported yet in the services, and so on. So there is a lot of headache in case you migrated everything and you have no way to migrate everything backward. So we support both forward migration and backward migration. And there is, in case that user wants to implement a really complicated migration, like as I told before, when user need to move data not from one document to even different collections, for example, we support migrations called free-fall migrations. It means user just set up all the logic of the migration into this Python module, and we just go forward and backward as well as we did before. So in general, there are simple way, like we just set up mapping between old and new documents, and it works. And there is a more complicated way called free-fall migration, where users set up everything on their own.
Fantastic. Thank you so much for that very, very thorough explanation. I really appreciate that. And I wanted to show, so you had some resources. I wanted to allow all the watchers to see those resources as well. Let me put my screen up. I believe it is, there we go. Okay, so all the watchers, if you have any questions from Roman's demo, please leave a question for us to answer later on. If you have general questions, that would be awesome as well, and we'll answer them as soon as we can. But I wanted to not switch gears, but I had, there's been recent talk about, motor being depreciated recently. And I kind of wanted to ask a question to you, Shubham, about that, about motor being depreciated in favor of async, API, and PyMongo. We've had a lot of people from the community ask about this. We wanted to bring that up. Can you explain kind of what drove that decision and how it could impact existing projects?
Yeah. So historically, Python team, we maintain two separate libraries for Python. PyMongo for synchronous use case and Motor for asynchronous application. However, Motor was built as a wraparound PyMongo, and while it exposed an async IO compatible interface, it didn't really deliver the full performance benefit of true async IO. And under the hood, it relied on threads to handle blocking operations, which introduced overhead and limited the scalability for highly concurrent applications. So in recent years, the Python ecosystem, particularly async IO, has also matured a lot, and we saw an opportunity to take advantage of these improvements to deliver a more efficient and streamlined solution for async workload. At the same time, maintaining two separate libraries was also sort of like a tech debt for our internal team as well. So about a year ago, we began proof of concept to integrate native async support into the PyMongo itself. And after several iterations and internal testing, we released async API in PyMongo May 14th. We did the GA release. And our internal benchmarks show performance gains of up to 10 to 30% for highly concurrent workloads if you're using async API in PyMongo. So that's a win-win. And for developers who are currently using Mora, the migration path is pretty straightforward, and we have published the migration guide in our documentation as well. And I think Roman also recently migrated from using Mora to async API in Beanie, and I think probably we're going to talk a little bit about that as well. So I would love to hear what Roman has to say.
Actually, we created the PR to migrate from Motor to PyMongo, half a year ago, when it was just after the first message that PyMongo will support asynchronous way. We immediately created this thing, and we were migrated. It actually was straightforward. We only had to remove everything about Motor from our code base and replace with PyMongo. But we introduced a few breaking changes because of the naming convention. Like before that, for the model, we named collection as Motor collection, and we could not name it this way anymore. And this is why we introduced the Beanie version 2. It only, the major change there is it supports PyMongo async way instead of Motor, but as soon as it's a breaking change, it's a second version of Beanie now.
Yeah, that's awesome. I was going to ask about that because I know that Beanie version 2 was released last weekend, right? So it's very new. Have you heard any feedback from the community about them using version 2, or what are some features that you can talk about besides PyMongo?
Actually, this is a good news. We didn't hear any complaints about this. It means we created everything correctly, because usually after major or even small release, if we introduced some, incompatibility, some bugs and so on, we immediately can see the audience reaction. While if we just make a smooth version bump, without any bugs introduced, everything is quiet in our channels, and this is a good sign. So version 2 is a quiet version, so nobody complains.
That's perfect. That's awesome. You got a shout out. I put it on the screen, but I'll put it here again. Huge shout out. Many thanks to Roman for creating Beanie Little Rocket Ship. That's awesome. I know a lot of people are very excited about, Beanie in general. So it's awesome to have you here. Another question that I had was, a lot of people use, Fast API, Flask, Django. How does Beanie integrate with those popular frameworks?
So as soon, one of the reasons to create Beanie was to support the new stack, and by design it was supporting, like it was implemented on base of Pydantic, which means it can be integrated into Fast API really smoothly. In Fast API, there are a few corner cases how it creates, for example, how it creates open API contracts and so on. And Beanie supports such corner cases as well, to only show the necessary information, like without showing fields that we use only under the hood and we don't want to expose them, for example, in the contracts, and so on. So by design, it's Pydantic stack, and it supports well by Fast API and other Pydantic-based frameworks and libraries.
Nice. Considering all the talks of the new features and the things coming up, what's the near future for Beanie within the next 6 to 12 months? And what should we get excited about?
So actually, Beanie currently is a very stable library. Like the time when we introduced it, new big feature every few months was like 2-3 years ago. Currently, we mostly work about performance, scalability, and other stuff. So currently, I'm working on making Beanie a bit more lightweight on a startup, because Beanie is not only used in microservices where the warm-up step could be so it can be long and it's not a problem, but Beanie is also used in Lambda functions and alternatives in different cloud providers where this is critical, like how fast library could be initialized, for example. So currently I'm working on this, on making initialization step lightweight, making everything as lazy as possible, and so on. So mostly working on performance and scalability, because this is critical in our time as well. Yeah, I think that's the answer.
Perfect.
Thanks.
Thank you so much for that. Okay, so I have a little question. If people want to contribute to Beanie, what is the best way for them to do so?
Yeah, we already have a team of contributors, and I super appreciate their help, and they do most of the work already without me. Like last year, probably they are super active as developers, as community managers, and so on. We have a Discord channel where we communicate, where we plan our new features and what we can do and what we actually should do, and we help others, people who just joined community or started to work with Beanie. There are special sections there, like help and other discussions. And if you want to help with Beanie development, please join our Discord server. And so we have a few groups there, public and private, where we can discuss how you could help.
Perfect. And then is the Beanie Discord the best way for anyone who's watching to get in touch with you?
If you just faced like a problem, like issue or any bug, you just can send GitHub issue. And it would be enough. We read all of them and we try to answer fast. And if it's critical or high important, we for sure will solve it fast as well. But if you want to chat, to talk, it's better to go to Discord server. Yeah.
Perfect. And so which resources do you recommend that developers look at when they're first getting started with Beanie?
We have a documentation on the website beanie-odm.dev. It's a well-written documentation, comprehensive, like it's written in shape of tutorial. It means we try to explain every usage scenario and how it could be covered by Beanie features. So please firstly go there. There are fast start section and comprehensive tutorial documentation there. I think you will read everything you need for your first steps there. And yeah, and you can go to the GitHub channel as soon as this is Python. You just can read the code itself. It's pretty clear to understand the logic there. So if you faced any corner cases and you want to dig deeper, you just can read the code.
Perfect. And you're getting a lot of love in the comments right now. But from everyone who's watching, if you have any questions at all, now is the time for you to ask all of them. You can ask the experts yourself. If you have any questions for Shubham, any questions for Roman, any questions for me, any questions for Afi, please feel free. But yeah, that demo was incredible. The explanations were fantastic. The questions asked were great. So I just want to say, Roman, thank you so much, for taking the time to be here. I know that Beanie is super beneficial for so many developers. Oh, I'm seeing that we have a couple questions. Okay, so what are the best practices for creating composite or text indexes is the first one. And then there's another one, but I'll answer that. Or I'll ask that after the first one's answered.
So it's always hard to answer such questions without knowing the context of the load profile, of the how big the collections and so on. I'd say you have to, like, if you need compound index, then you understand that you query using that combinations of these fields, and you already understand your load profile. So then you just have to create such a combined index, and it will work. If you don't understand your load profile, you probably have to create some load tests to understand what is hot pass for your querying, like what is the most frequent request and for which request you spend the most time. And then, like, the most time is literally in milliseconds, like which request, single request takes a lot, the most of the time. And in Zoom, like, there are situations when single request is very slow, but you request it like a few times per day. And there are more or less fast requests, but you shoot them like 1,000 times per second. And actually, this is a place to improvement. So yeah, and then you can just understand what you're looking for, and exactly how you look it for. You should set up your indexes. This is a best practice.
Perfect. And then do you have any advice for indexes on vector fields? That is the second part of the question.
Sorry, could you please repeat on which field?
On vector fields?
Yeah, I see. Actually, I'm not that experienced in that field. I'm just playing with this, so I cannot have expert opinion about vector fields. But yeah, it's fun. It's fun to play with them. So I'm just starting to play with them as well. So sorry, audience, but I'm not the one who could answer this.
Roman, yes, we can chat offline about this. We've been working internally on a project for adding vector source capability in some of the ODMs, and I think this is a great collaboration opportunity for us to talk next. I'll set up some time for this.
Yeah. And then you have some more love from Marco, who's saying that it is his favorite MongoDB ODM, which is awesome.
Thank you. It's my favorite as well.
Well, mine too. Roman, you do a great job at not only creating the library, but maintaining and keeping it in a great shape.
Thank you.
Thank you so much. And thank you everyone for joining. If you have any questions left over that we weren't able to ask, please just leave them in the comment section of either the YouTube link or the LinkedIn link, and then someone will definitely be able to get to you. But if no one has any more questions, then we can end the live stream here. Thank you everyone for watching. Thank you, Roman and Shubham and Afi, for joining me today. This has been a ton of fun.
Yeah, thank you so much. Bye, everyone.
Thank you very much.